Okay, we're going to look at this first question, which is constant acceleration in 2D and Newton's second law in 2D using vectors. Okay, so what is Newton's second law? It's the first one we're going to use here. So we're given some forces, we're given a mass, and we're trying to find the acceleration. So Newton's second law tells us that F equals ma. Now we've got two forces, we're going to add them up. So even if you see in a question it talks about resultant, it just means the result of adding the two up. So we're going to try find the acceleration. We rearrange that, we get F over m. So we've got 8i plus 9j plus minus 2i minus 7j, all divided by the mass, which is 0.6. So what I'm going to do in my calculator is I've got 8 minus 2, which is 6, divided by 0.6, which gives me 10. So I've got 10i, and then I've got 9 minus 7 divided by 0.6, which gives me plus 10 over 3j. And that's my acceleration, so it's meters per second squared. Then it says at time t equals 0, the velocity is minus 12. That's nice. At time t equals 3, p goes through the point A, and then F1 is removed, and only F2 is used. And then at t equals 8, so between here we've got 5 seconds, it goes to point B. Right, so what essentially we need to find out is where the velocity of P when it gets to A. So when it does that, it means it's its starting velocity for its journey from A to B. So first we're going to start with V equals U plus AT. Now that's one of your SUVAT formulas which you're given. So there's our SUVAT formulas in our formula book. So exactly the same way, we've got V equals, so we're starting off with minus 12j, so that's our U, plus your acceleration times by time. And we've got 3 seconds, 10i plus 10 over 3j. So let's do our i's first. Now it's quite confusing when you have just j, so if you have to write 0i for yourself, do that. Right, so we've got 3 times 10, so 30i, 3's cancel, so I'm going to have 10 minus 12, so minus 2j. Okay, so that's going to be my velocity at t equals 3, which is also going to be my opening velocity for the journey from A to B. Okay, so now what do we know? Now we need our new acceleration. So we're going to have a new acceleration. We already did A equals F over m. This time the force 1 is removed and we've only got force 2. So minus 2i minus 7j over 0.6. So we get minus 2 divided by 0.6 to give us minus 10 over 3i. And then we've got minus 7 divided by 0.6 to give us minus 35 over 3j. Okay, so that's our new acceleration, and we want to know how far it travels from A to B. Now we don't care about where it starts because we're just trying to find the distance it moves. So we're going to use S equals UT plus a half AT squared. Our old V, this V here, becomes our new U because that's the speed it's going at 3 when everything resets and we get this new acceleration. So it's going to become our U that we use, 30 minus 2. Our T is 5 because 8 minus 3 is 5. Plus a half. I'm going to write it this way around just because it's easier to sort the numbers, and because I made the question up, the numbers probably don't come out very nicely. So we end up with 30 times 5 plus 0.5 times minus 10 over 3 times 5 squared. So we end up with 325 over 3. Then we've got minus 2 times 5 plus 0.5 times minus 33 over 3. Oh, was it 33 over 3? 35 over 3, sorry. Can't read my own writing. So we've got 35 over 3 times 5 squared. Right. And we get minus 935 over 6. So we've got 325 over 3 minus 935, so that's I, minus 935 over 6 j. Now that's going to be my displacement of A to B, so like the vector going that way. If I want the distance, I've got to square and square root it. So I'm going to take 325 over 3 squared, and it doesn't matter whether it's positive or negative, because it all becomes positive. And if I stick that into my calculator, like I said, hopefully their numbers will be a bit nicer if you do any questions like this. But you never know. You know, sometimes the numbers come out horrible and we just assume we've done it wrong. And we want that to 1 decimal place. So I've got 189.8 meters. Explain why the distance travelled as it moves to A and B is not the same. Well, for A to B, when we're talking about in vector form, we assume it's moving in a straight line. So you're going to say the particle P doesn't move in a straight line.